Hey guys, welcome to Path to Math. I'm Dante. Today we're going to cover the discriminant and how it relates to the quadratics on the SAT. The discriminant will tell you how many solutions there are to a quadratic based on the equation, which there are times that the SAT expects you to know that information just from the equation, no graph given. So no need to graph either, because if you can find out that the discriminant, which is b squared minus 4ac, is greater than 0, then you know that there's two solutions. And so I drew that graph in green. That's what that graph would look like as an example. There's going to be two x-intercepts. That word solution translates into x-intercepts, not y-intercepts. Moving on to if b squared minus 4ac, which again is the discriminant, equal to 0, if it's equal to 0, there's going to be one solution. I drew that graph in red. You could see there's only one point where the graph touches the x-intercept. It doesn't matter if it's facing up or down in any of these examples. Moving on to the blue graph, you see it's kind of floating out there, and you can see I need a new blue marker. The b squared minus 4ac being less than 0 tells you that there's no solutions. There are no x-intercepts. So you can see that this blue quadratic is just floating. It doesn't matter in what quadrant, facing up or down, it just doesn't cross the x-intercept. Now, we can determine all of this from an equation once we have it in standard form. So let's talk about standard form very briefly. Standard form is going to be ax squared plus bx plus c equals 0. That equals 0 is very important. They're going to give us problems where we have to set it into standard form. So let's cover that. We have to use the coefficients into the discriminant, b squared minus 4ac. That's where these three letters come from. Don't be overwhelmed by that. Once we have it in standard form, we could quickly extract that information. Let's start off with a practice problem. For example, they might say, how many solutions are there for the following function, f of x. So let's say f of x equals negative x squared plus 5x plus 2. Alright, now this isn't set equal to 0, but basically that f of x can be replaced with a 0. So we can have 0 equals negative x squared plus 5x plus 2. Let's identify the various coefficients and plug them into the discriminant. Our a value is a negative 1. There's that negative sign. Our b value is a positive 5, and our c value is a positive 2. Let's plug that in. We have 5 squared minus 4 times a negative 1 times a positive 2. We want to see if our end result is either equal to 0, above 0, or less than 0. And that's that first step that I showed you. That's the foundation we're going to be building off of. We have 25 plus 4 times 2. I got the plus 4 because the minus 1 will cancel with the negative sign. That's going to leave me with 25 plus 8, which is 33. Not that I need to know the specific number. As long as I figure out that it's a positive number, that means that there's going to be two solutions. And so to answer this question, it would be two solutions. Similarly, let's try x squared minus 6x plus 9. b is a negative 6, a is a positive 1, and c is a positive 9. I have 36 minus 4 times 1 times 9. That's going to be 36 minus 36. That's going to give me 0. Do you remember how many solutions there are if the discriminant is equal to 0? That's going to be one solution. In other words, one x-intercept. And remember, I'm basing all of this information off of the discriminant right here. So for the next equation, or function, let's do negative 3x squared plus 6x minus 3. b equals a positive 6, a equals a negative 3, and c equals a negative 3 as well. Notice that I tend to write my coefficients b, a, c because that's the form That's the form of the discriminant. That's the order that the discriminant goes in. So we have 36 again, minus 4 times a negative 3 times a negative 3. Well, we have the two negative 3's canceling the negative sign. We have 36 minus 4 times a positive 9. And then we have 36 minus 36 again. So that's also 0. That's also going to be one solution. I did this to show you that there's no cheat code in finding out the solution just by glancing at the original function. There's no real telltale sign. You have to actually use the discriminant to help you determine how many solutions there are on that quadratic. Let's do one more question that's like this. If f of x equals, for example, a 2x squared plus 6x plus 5. B equals 6, A equals 2, C equals 5, 36 minus 4 times 2 times 5. That's going to be 36 minus 8 times 5. 36, minus 40. That's going to be a negative number. Obviously, it's negative 4, but it doesn't matter the specific number. As soon as it's a negative number, there's going to be no solutions. Any negative number for your discriminant is no solution. And a brief explanation why is because if we look at where the discriminant comes from, we're not allowed to have a negative number for the discriminant. Anybody know where the discriminant comes from? If you recognize it from the quadratic formula, good job. So notice that the discriminant is under that square root. If our discriminant simplifies to a negative number, like negative 4, for example, that's an unsolvable operation. That's an inoperable term. We can't simplify that at all. That's an impossible situation. So because there's a negative number, that tells me that there's no solution. There is no intersection with the x-axis. Can't have that. Alright, let's continue with a different type of problem. Let's make this a little bit more difficult. The SAT loves these types of problems that we're about to practice. They're going to present to you an equation. Let's say 2x squared plus bx plus 1 equals 0. They'll set it equal to 0. And let's say find the value of b when the graph has one solution. And they could term that in a lot of different ways. For example, they could say determine the value of b if the graph only has one solution. Different ways to say that. But basically, we have to take the information that we learned about the discriminant and apply it to what we have here. Well, I know that when there's one solution, I know that the discriminant is equal to 0. Okay, so follow along here. I know that one solution means this in the green marker. I also know a couple of these variables. I know the a and the c. I know that a is, in this case, 2. C is a positive 1. B is b. So we're just going to keep that the same. Plugging that in, we get b squared minus 4 times 2 times 1 equals 0. All we have to do, guys, is solve for b. We get b squared equals 8, and then b equals plus or minus the square root of 8. We have to simplify that as a radical. So I know that 4 times 2 is 8. And I know that the square root of 4 is 2. So my real answer is plus or minus 2 square roots of 2. It's plus or minus because b is a square. It is an exponent. And what that will do is kind of imagine translating or flipping the quadratic. Whether it's a negative b or a positive b, it doesn't matter. So plus or minus 2 square roots of 2 would be your final answer. Let's try another one, but change up the graph, the equation. Let's have negative 6x squared plus bx equals a negative 7x squared minus 5. This equation is very different, and don't think that a is negative 6. If you think that a is negative 6, you'd be wrong. You first have to set this into standard form. That's what they expect you to do, all on your own. They're not going to give you that tip or hint. So let's do that. We have to combine like terms by adding 7x to both sides, 7x squared to both sides. And then I'm also going to add 5 to both sides. I want this to be set equal to 0. So we're left with a positive x squared plus a bx plus 5, all equals 0. And now I can set my discriminant equal to 0. I know my discriminant has to be equal to 0 because they're only asking for one solution. So we have b squared minus 4 times 1 times 5 equals 0. I took my a term, my b term, and then my c term. All right, there is an invisible one that out there in front of the x, and I plug that into my discriminant, right? So solving for b, we get b squared equals 20. B equals plus or minus the square root of 20, which is also equal to 2 square roots of 5. Plus or minus 2 square roots of 5 would be the final answer here. Let's switch up the amount of solutions. They're going to reword the whole problem. They might say something like, find the maximum value for b if the graph has no solutions. Let's change the equation to negative 3x squared minus bx equals 4. First step is to get it into standard form. So I'm going to subtract 4 to both sides. And now I'm in standard form. Now they're telling me that there has to be no solutions. And if you remember, no solutions means the discriminant is less than 0. So we have b squared minus 4ac is less than 0. That's what we need. That's why they use the term maximum. We have to find the value that is closest to allowing us to be less than 0. We have b squared minus 4 times a negative 3 times a negative 4 is all less than 0. Simplifying that right hand side, we have a negative 12 times 4, so that's a negative 48. And then we have b is less than the square root of 48. And 48 can be simplified using 16 and 3. So that would be 4 square roots of 3. Plus or minus 4 square roots of 3. So the maximum value has to be plus or minus 4 square roots of 3. But be careful. We have to be less than that. So anything less than 4 square roots of 3 would be our answer, because there's no equal to symbol on the inequality. If there's an equal to symbol, then we can include 4 square roots of 3. But since there's not an equal to symbol, we can't. All right, let's move on to a similar style of question. Let's say they want us to find the missing value of a. It's not going to change our process too much, but let's get the practice in. So, what value of a causes one solution? And let's say the equation they give us is ax squared plus 2x equals 5x plus 3. Right off the bat, we put it in standard form. I'm going to subtract 5x to both sides, and then subtract 3 to both sides. It's going to leave me with a negative 3x and a minus 3 being set equal to 0. So now I can determine all my coefficients, and the phrase one solution, means that we're set equal to 0. Our discriminant is set equal to 0. So we have negative 3 squared minus 4 times a times a negative 3 equals 0. 9 plus 12a equals 0. Sorry, that's a 9. 9 plus 12a equals 0. We're going to subtract the 9 and then divide by 12. Subtract the 9 and then divide by 12. That's how we solve for a. That's going to simplify down to negative 3/4. So we need a to be negative 3/4 in order for this graph to have one solution. This last practice problem is a big one. It's definitely a difficult problem that the SAT is going to give you. Furthermore, it could be on the FRQ response section with the grid in. So let's go over this. Find the largest integer a can be if there are two solutions for the graph. And the equation they give you is ax squared plus 7x minus 2 equals a negative 4. I would love for you to try this on your own first. I'm going to start breaking down this word problem. That's the key with the SAT, is being able to interpret these words. So something that you want to highlight is the largest integer. That's our end goal. However, they also told us that there's going to be two solutions. So I know that we're talking about the discriminant. Furthermore, I know that we're talking about b squared minus 4ac, the discriminant, being greater than 0 because there's two solutions, right? If I get this in standard form, all I have to do is add 4 to both sides. So I'm going to erase this and put a positive 2. Okay, so that's going to be set equal to 0. Now I could plug this into my discriminant inequality. We have 49 minus 4 times a times a positive 2, all being greater than 0. I'm going to subtract the 49. That's going to leave me with a negative 8a is greater than a negative 49. To get rid of that negative 8, I have to divide both sides by that negative number. And when you divide or multiply both sides of an inequality, you have to flip that symbol. So we have a is less than 49 over 8. That's a key detail, is being able to flip that inequality. Don't forget that detail. Now 49 over 8 is approximately 6.1. And we want to find the largest integer that we can have for a given the situation. So would your answer be 7 or 6? Okay, your answer should be 6. You can't go any higher than 6.1. A has to be less than 6.1 is a great way to interpret that inequality. So our answer is going to be 6. That's the largest integer that a can possibly be if there's two solutions. It's true that 5 is a viable answer to give us two solutions, but the question specified for the largest integer, not just any integer, but the largest one. So we have to pick 6. Alright guys, that's going to wrap up our work for today. Thank you for supporting Path to Math. I hope this really helped you out with your SAT studies. Any questions, leave any comments down below. Other than that, have a great day.